Hi everybody, welcome to another video in linear algebra, section 2.5, matrix factorization. Factorization of a matrix is an equation that expresses A as a product of two or more matrices in order to organize data in A in more useful ways or more convenient computation. So there are a lot of different factorization. In this section we focus on LU factorization. In this case, that will allow us with more convenient computation. Now, of course, we talk about the solution of matrix equation AX equal to B many times, and of course we know a lot of different ways to solve for it. Now, if we need to solve for it all with the same coefficient, suppose we have AX equal to B1, AX equal to B2, and so on. If we use A inverse times B1, A inverse times B2, of course that certainly works. However, row reduction in that case is will be more efficient. So if we decompose A into L and U, that will save us the computation. By the way, just as one of the homework problem in previous section, we can put, if we have to solve a bunch of them like this and we have the calculator, I could put that into a matrix of B, A, and then B1, B2, and then B3 all the way to BP, and just do the reduced row echelon form. And that will turn into a bunch of different solutions for B1 to BP. Right. Now, but the more efficient way is to use LU factorization. You'll see why in a minute. Right. Assume A is an n by n matrix. So first of all, this doesn't have to be square, right? So right at the get-go, that will be the advantage of this, because in order to use A inverse, it had to be square, right? So this is a step up from that already. That can be reduced into echelon form without row interchange. So this is only echelon form and not reduced row echelon form, and we do that without row interchange. So the one we use the calculator, it doesn't work because that involves some row interchange. Right. So when we do that, we decompose A into two matrices, one of which is the diagonal lower triangular, where we have one on the diagonal. So one matrix we have one on the diagonal, and this is lower triangular, meaning above the diagonal will be 0, below it could be anything, but on the diagonal it's going to be 1. So that is the matrix L. The matrix U is just the echelon form of A. That's easy. Again, no row interchange here. Right. Now let's just say somehow we decompose A into L times U. Then to solve this equation, what we do is we're going to let Ux equal to Y, and then we turn the equation into Ly equal to B. Once we solve for Y, then we can solve for X. You see. Right. By the way, there's a typo in the note, so this should be -1. Right. So first example, verify that this matrix can be decomposed into these two matrices. Once again, we have the matrix L and the matrix U. This is the lower triangular matrix, because below the diagonal is 0, lower triangular matrix, above the diagonal 0, below it could be anything, and on the diagonal is going to be 1. So that is the L matrix in this case. And U is indeed the echelon form of A. Right. Of course, we asked to verify that, so all we do is just multiply these two together. To save time, I already entered in the calculator, and that's why I found there's a mistake here. Alright. Right. 1001 negative 1000 negative 110 2, negative 5, 1, negative 3, 8, 3, 1. Okay, that's good. And then 3, negative 7, negative 2, 2, 0, negative 2, negative 1, 2. Okay, anyway, all the numbers multiply together, and in this we have 3, negative 7, negative 2, and 2, negative 5. Of course, there's a way to find this. On the first example, we just check. Right, now we have A decomposed into L. Now note that A can be decomposed into L and U. We can use that to solve the system of AX equal to B. In this case, B should be a vector. I will change that on the note before I post that online. Right, first we're going to solve for Ly equal to B. So once again, the Lu times X equal to B. So first we're going to let Ux equal to Y, and then we have the equation Ly equal to B. So for that we can have Y, and then when we have that we can solve for Ux equal to Y, and we can get X from it. Right, now Ly equal to B, and we solve for Y. This is the matrix L. Times Y. So we're just going to say Y1, Y2, Y3, Y4 equal to B, negative 9, 5, 7, and then 11. Right. Now, of course, we just put this in the matrix and then do reduce row echelon form. That would be easy. But this one we can solve by hand, and that is the reason that we should be able to do this by hand. Now, let's look at the first equation. It's going to be y1, 1y1 equal to negative 9. So we have y1 equal to negative 9. I have to pause the video to replace the ink. Right, so that's good. Y1 equal to negative 9. On the next equation, what we have here is negative y1 plus y2 equal to 5. And from here we can solve for y2 equal to 5 plus y1 so we have y2 is equal to 5 minus 9 minus 4. And now the third equation, 2y1 minus 5 y2 plus y3 equal to 7. So we solve for y3 equal to 7 minus 2y1 5y2. 7 minus 2y1 is negative 9 plus 5 y2 is negative 4. We're going to have 5 and then from the last equation, negative 3 y1 plus ay2 plus 3y3 plus y4 equal to 11. So we have y4 equal to 11 plus 3y1 minus ay2 minus 3 y3. So y4 equal to 11 plus 3 y1 negative 9 minus 8 y2 negative 4 and minus 3 y3. We have 1. So with that we have y1, y2, y3, y4. That vector is y, which equal to negative 9, negative 4, 5, and 1. Right. The reason when we write the low triangular matrix we can solve for by hand, and this is what we call the forward substitution. So we start from y1, y2, y3, and so on. Now, once we have y, we can let ux equal to y, and then we solve for x. Now we have ux, the matrix U is going to be that. Just going to copy here. And we have u multiplied by x. Let's say it will be a vector equal to vector y, which is what we just have. By the way, the note online, I've already fixed this. Because most of this problem rather complicated, so I just write the solution here in case I make a mistake, so I know. By the way, sometimes when we write the solution, we write that instead of the vector. We just said this is going to be a row matrix and then transpose, which is the row turned to the column, and that was its vector column. Right, you can just write like that. Now, from this one, if we have to solve for this one by hand, of course we're going to go with the bottom equation, then we work backward. So this is called the back substitution and the other forward substitution. Both of this I should be able to do this by hand. So this one, negative x4 equal to 1. So we can say, even then I should say negative 1. So we can say x4 is equal to negative 1. Next we have this equation, look at backward substitution. Negative x3 plus x4 equal to 5. So we can solve for x3 equal to 5 plus x3 equal to x4 minus 5. x4 minus 5, so that minus 6. And then next we have this negative 2 x2 minus x1 plus 2x3 sorry plus 2x4 equal to negative 4. So here we can solve for x2 equal to, right, it's easy, we just move it is going to be, I've just moved x3 and x4 to the other side, so we have negative 4 plus x3 minus 2x4 and then divide by negative 2. And we have 4. And finally, from the top equation, we can have 3x1 minus 7x2 minus 2x3 plus 2x4 equal to negative 9. And from this we have x1 equal to, right, so move all of that to the other side. So I have negative 9 plus 2x7x2, 7 times x2 of which is 4, plus 2x3 which is negative 6, minus 2x4 which is negative 1. And when we move everything on the other side, I have to divide by 3. And we have 3. Yeah. So this is called the backward substitution, and this is forward. And of course we can just do this by hand, just run out of space. So we have x equal to x1, x2, x3, and x4. 3, 4, negative 6, and negative 1. Right. Of course, if you look at the solution on the note, I will update this before I post online. Right, so that's good. Now the question is, how do we know how to decompose A into LU? Of course, it has to be relatively easier than what we use the reduced to echelon form. And in fact, that is rather simple. What we do is reduce A into the echelon form, and then we keep track of the operation that we need. And then after that, we're going to have that place entry in L, and using the same sequence of operation that reduce L. Of course, when we see it in the sample, you get an idea. Let's look at this example. Now we try to decompose this into echelon form, and then from there we will form the matrix L. And of course, when we have the echelon form, we're going to have the matrix U. Right. So again, we do not want to use row interchange, and we don't divide row by the multiply a row by a constant either. So we're just going to keep on the pivot, and then not equal to 1. That's perfectly fine. So first, if this is in the echelon form, the way we define it is that we're going to turn the negative 4 here into 0, and we turn the 2 here to 0, and we turn the negative 6 here to 0, all of which based on the pivot of 2. So we're going to do 3 of operation. We're based on row 1, and in order to eliminate this, we have to multiply by something. Right, to eliminate negative 4, we multiply by 2, right? So 2 times 2 is 4, minus 4 is 0. So we're going to multiply 2 here in row 1, and then add and replace into row 1. And then we multiply negative 1 oops, sorry, 2 and 2. This is 3 and 3. And then to get negative 6, we multiply by 3, row 1, row 4 into row 4. Right. I'm just going to store, and I'm using a calculator here. First, this is a 4 by 5 matrix. Unfortunately, we cannot just hit one button. We have to do a bunch of operation. 2, 4, negative 1, 5, and negative 2. Negative 4, negative 5, 3, negative 8, and 1. 2, negative 5, negative 4, 1, and 8. Negative 6, 0, 7, negative 3, and 1. Let's check. Right, just hit enter. Now we do this operation. Of that, I'm going to use the calculator. Right, so second matrix. This is the operation. We need to multiply a row by a number and then add. Right, so we multiply by a row first. We multiply by 2 into the matrix. So what is the matrix? Remember, we enter the matrix and then we hit enter. When we hit enter, the last answer is stored into answer. So we're going to hit second answer. That means the last matrix, the last result, we're going to recall that. Hit second, that negative sign. And then we multiply 2 into row 1 and add to row 2. Right? And of course that turned into 0, which is good. Now keep doing this. Just copy and paste. Now we use multiply by negative 1. If we want to insert, hit second insert negative 1. Now have to delete the 2. Negative 1 using that matrix, multiply to row 1 and replace into row 3. Add and replace to row 3. Of course that's going to be 0 now. And then again, just copy and paste. Now we just need a 3 here, multiply to row 1, add and replace to row 4. Right, that's the result. I just copy it. 2, 4, negative 1, 5, negative 2, 0, 3, 1, 2, negative 3, 0, negative 9, negative 3, negative 4, and 10, 0, 12, 4, 12, and negative 5. So we're done with the first column. Let me check the answer first. Right, it's right. Now we got the first pivot, which is good. Now we're on to the second one, which is on the immediate one. So this has to be this one. Now with that, we're going to turn this to 0 and that to 0. Right. Again, we're just going to keep 3. We don't divide everything by 3. So in order to, now the pivot is at row 2. To eliminate, to get to negative 9, we're going to multiply by 3, right? 3 times 3 is 9, minus 9 is 0. So we need 3, add and replace to row 3. Now we need 12. 3 times 4 is 12, but it have to be negative. So we use negative 4, add and replace the new row 4. Right, good thing we already have this. Just copy and paste. Now 3 times row 2, add to row 3. Of course that is 0, right? And then once again copy and paste. So we multiply -4, multiply to row 2, and add and replace to row 4. Apply to that matrix. That's the nice thing about the answer. They are using the answer here. I just keep update the matrix. We don't have to do anything. And now we see we have 0, 0 below the 3. So let's just copy that result. The first 2 rows should stay the same. Then 0, 0, 0, 2, 1, 0, 0, 0, 4, 7. Right, so I have to pivot here, here, and now this will be the pivot. We just need to turn this to 0. And to do that, the pivot now is on row 3. And we add and replace to row 4. But in order to eliminate 4, we're going to use 2 times 2 is 4, but it's going to be opposite to that. And then we just need to do that operation. -2, multiply to row 3, and replace, add and replace to row 4. Here we have to pivot here, here, here. Well, that is in the echelon form. So this is U. So now we have the matrix A equal to the L matrix. By the way, if we decompose this into L and U have the same dimension as A, right? Because U is the echelon form of A, so U have to be 4 row 5 column. In that case, L have to be a square matrix, so it have to be 4 by 4. Right? U and A have the same size, and then L have to be a square matrix, so it have to be the same number of row and columns. So we have to have 4 by 4. Furthermore, L have to be the matrix of lower triangular. We know that is going to be matrix L. And the matrix U is what we just have. I'm just going to copy it. what do we put below the diagonal? Well, those are the numbers that we used earlier. It's going to be there. Notice that for the first pivot, the first column, we use those three numbers. So we're going to put those three numbers, but have to be opposite to it. So I'm going to have -2, 1, and -3. -2, 1, and -3. Next, for that pivot on the second column, we use these two numbers, and we turn the opposite to that, -3 and 4. Opposite to those numbers. And for the next pivot, we're going to use -2. Just switch that to 2. Even though this is in the fourth column, but don't worry about that. This is for the first pivot, second pivot, and third pivot. So 1, 2, and 3. So that is convenient. By the way, the number we multiply, just turn to opposite and put in the L matrix. Remember, 2, -1, and 3, -2, 1, and -3, 3 and 4, 3, -4, -3, and 4, and then 2. Right. So we just need to check. I'm using the matrix L. One, -2, and 1. 1, -3, and 1. -3, 4, 2, and 1. Now, what is U? Well, the U is the last matrix we have. Can we just copy and paste? Nope. In that case, just use what we have been using. Second answer, right? The bad thing about this is, if one step we make a mistake, we have to go from the beginning, because the answer only stores the last answer we have. Alright, and that should give us the original matrix. Yeah, so simple enough. Just do find the echelon form, don't interchange row, don't multiply by the row by any constant. And then when we eliminate, use the opposite number as we eliminate, put in the L matrix. So that's what we do here. Now let's try another example. Find the LU factorization of this one. Right, much better. Just enter that matrix in. Two, -4, 2, 1, 5, -4, -6, -2, and 4. Right. Now, so the pivot here, turn this to 0, turn this to 0. Right? How do we eliminate the 2? Based on eliminate 1 based on row 1. Well, in order to get to 1 from 2, 2 times 1/2 is 1, but we want opposite to that, and then we can add and replace to row 2. And then that to 0. We get to -6. We multiply by 3. 2 times 3 is 6. Minus 6 is 0. So that 3 is good. Add and replace to row 3. Right. Let's do that. And we have second matrix. Of course, we can do this by hand, but I just say, of course, we can just 1/2. apply to the matrix, second answer. So that's why when we enter this, hit enter, so that we store into the answer. Multiply to row 1, add and replace to row 2. Alright, so that's 0 is good. Now we multiply by 3. Add and replace to row 3. And that is 0 here. It's good. So let's copy the answer. Of course, we can just keep going with the calculator. Of course, when we look at the answer, we can just determine what next step we need. However, when we write this down, we have those numbers that we will store into the lower triangular matrix. So that's why we keep tab of it by writing in this row operation. Now we have the pivot here, which is good. Now the pivot go into this one, and now we turn this into 0. So now based on row 2 to negative 14, that obviously we just need to multiply by 2. Alright. What happened? Oh. Now multiply by multiply by 2, apply to the matrix, the last matrix we have, multiply to row 2, add and replace to row 3, right? That's good. 2, negative 4, and 2, 0, 7, negative 5, 0, 0, and 0. Now the pivot is here, and here, row 0, so actually we're done here. This is equal to the matrix U. So in computer science, back when I learned the column equal, meaning we're going to make that equal to U, or let U equal to that. So now we write out A is equal to LU. Now we can check the dimension. A is obviously 3 by 3. And then we have L and U. U has to be the same dimension as A. And then we take 3. L has to be a square matrix, so all of them are 3 by 3. Right. And L is upper triangular matrix, so we have diagonal. Above diagonal is 0. Now below that, we're going to use the opposite to the numbers that we use here. That for the first pivot, use opposite to that. And then for the second pivot, we only have 2. Use opposite to that. Right, and that is L, and we have U here. Right, and of course the way we check is just multiply them. L is 1, just type 1/2 or 0.5, 1, negative 3, negative 1, 1/2, 1, negative 3, negative 2, and 1. Right. The last one, the last entry is U, so second answer, and there. 2, negative 4, 2, 1, 5, negative 4, negative 6, negative 2, and 4. Yeah. So simple enough. Just find the echelon form of A. Do not swap any rows. Do not multiply any row by any number. The only operation we can is add a multiple of this row to the other and replace. And keep tab of those numbers. Put opposite to those numbers into the L matrix, and that's pretty much it. Here we have one more example. Now, in this case we have to, before we do, of course, first we're going to decompose A into LU, and then we solve the equation AX equal to B. Right. So first step is decompose phi L and U such that A is decomposed into L and U. Right. Try to write small because we might not have enough space to do this long problem. Right, first just write down A is that. So we have the pivot here. Now turn that to 0. Now everything will base on row 1. To eliminate -4, all we do is just multiply by 1, right? And then add and replace to row 2. And then multiply by 2. To that would have to be, so it will be -2. Add to row 3 and replace to row 3. Right. I will enter the matrix first. Right, hit enter to store into the answer, and then that operation. One. Multiply to row 1 and replace into row 2. Right, so that 0 is good. Now do that, but use -2, negative, second insert, -2, answer, multiply to row 1, add and replace to row 3. Right, just want to write matrix here, 4, 3, and -5. 0, -2, and 2, 0, 0, and 2. Well, we're done. Because here we have the echelon form already. So this is going to be the matrix U. So we have LU equal to L, and U is this matrix. Yeah, if it's not 0, then we need to eliminate it, but we don't need to. Right. Now, we know L is lower triangular matrix, so above the diagonal 0. Below that, we're going to use opposite to the number we use to eliminate. So what do we put here? Since we're not using any number to eliminate, it's going to be 0. Right, of course. Then to check that, we just multiply the L matrix just multiply by the U matrix. Sorry. If you cannot copy and paste, just hit second answer. That will do. 4, 3, -5, -4, -5, 7, 8, 6, -8. So good. So that is LU. Okay. So that's the first step. The next step is to use LU to solve for x. So LU times x equal to b. So the first step is replacing ux by y. So we have ly equal to b. So from here we will solve for y. And after we have y, we go back to the equation ux equal to y. And from here we can solve for x. So the first step is using ly equal to b to solve for y. So solve for y in the equation ly equal to b. L and this is the fourth step. Y1, Y2, Y3 equal to B, 2, -4, and 6. Right, so this is the fourth step. So first, Y1 equal to 2. Right. And next, -y1 plus y2 equal to -4. So we can solve for y2 from here since we already know y1. So y2 is -4 plus y1. Therefore y1 is 2. Right. -4 plus 2 -2. Of course, we can also do this. Reduce to echelon form of that. Just of course, then we have to add b to it. So I don't know how to add the row into the matrix, so let's not do that. Of course, we can just use reduce to echelon form of the whole thing. Right, let's just try this first. Right, so -2, -2, -4, yeah, that's right. And then next we have 2 y1 plus y3 equal to 6. So we have y3 equal to 6 minus 2 y1. Y1 is 2. So y3, 6 minus 2 times 2. 6 minus 4 is 2. So vector y, y1, y2, y3 is 2, -2, and 2. Right. The last step is use x equal. From that we solve for x. So for x in ux equal to b, sorry, ux equal to y, because that's what we let equal to. Right, ux, this is u, x equal to y. Right. From here we just use what we did earlier is the forward step, and this is the backward step. So we want to go backward. Here we have 2x3 equal to 2. So x3 is equal to 1. Now this step, negative 2x2 plus 2x3 equal to negative 2. So we have x2 equal to negative 2 minus 2x3 divided by negative 2. So that step gives us x2 equal to negative 2 minus 2 times x3, which is 1, divided by negative 2. That's going to be 2. And from here we have 4x1, sorry, 3x2 by 5x3 equal to 2. And then from here we can just solve for x1, which will be 2 minus 3x2, which is 2, plus 5x3, which is 1, divided by 4, which is 1/4. Because I wrote the answer earlier in case I made mistake, so I know if I got the right answer or not. So it is correct. So in this case we have x is 1/4, x1 1/4, x2 is 2, and x3 is 1. So we have x1, x2, x3 equal to 1/4, 2, and 1. Usually in the book when they try to save space, they write the row and then transpose. It would turn into a column because a vector. Right. So that's what we learned in this section called the LU factorization. So first you need to know how to decompose a matrix into the LU factorization. So pretty much we go from A to U, which is the echelon form. Do not interchange rows, do not multiply a row by anything, and keep tab of the number that we eliminate. Using those numbers, turn to opposite and put that below the pivots, first pivot, and that's all we have in this example. In this one we have the first one, second, and third corresponding to the L matrix, first, second, and third pivot. Right, and once we have A decomposed into L and U, using this, solve for Ly equal to B, solve for Y, and then solve for X in Ux equal to Y. And that's what we have. And that's all we cover in this section. As always, thank you for watching, and see you in another video in linear algebra.